Okay, so we know that if a particle is resting in equilibrium, then the resultant of all the forces acting on it are zero, i.e. it's not moving, there are no forces going in any direction. What this means with vectors is if we have forces F1, F2 and F3, then if these forces are in equilibrium, then when you add them together to get the resultant, you get zero. So let's do an example of a question. Okay, so we've got four forces acting on a particle which is in equilibrium, and we want to find these unknowns A and B. So basically we know that 2, 3 plus 4 minus 1 plus minus 3, 2 plus A, B equals 0, 0. So this is what the zero vector is. This should be underlined here because it means 0, 0 rather than just 0. Okay, so we've got 2 plus 4, which is 6, minus 3 is 3, plus, so A is minus 3, and we've got, if we add these together, then we get B equals minus 4. So, if we have a particle P of weight 7 newtons suspended in equilibrium by two light inextensible strings attached to P and to the points A and B. So, here's A, here's B, here's P, and so this has got a weight of 7 newtons. So, we're going to think of this as a vector, 7 newtons. And then we're going to think of these forces as vectors as well. So, this is the tension. We'll call it TB because it's going towards B, and this is TA. Okay, now our next step is very clever. We're going to think about moving TA. So we're going to move TA over from there. It's going to be at the same angle, but it's going to go this way now. This is TA. And we're going to, instead of having this 7 going down, we're going to have it going down this way. 7 newtons, TA newtons, TB newtons. Okay, so this is a triangle of forces. They're all going in the same direction, so they're all cancelling each other out. So if we added these three force vectors together, we'd get 0. Now, because we've got a triangle, we can do some clever stuff. We can fill in some angles first. So this is dropping down at, so this is 90 degrees, so this must be 50. And this is, well, we can work out this is going to be 110, so this must be 70. And this is, well, take away 70 and 50, so this is going to be 60. So we know all the angles, and we can use the sine rule to find any unknowns. So first let's find TA. So we can say that TA over sine 50 equals 7 over sine 70. That's because our TA, which is this side here, is opposite this angle, 50, and our 7, this one here, is opposite this angle, 70. Okay, so now we can just rearrange that to say that TA equals 7 times sine 50 over sine 70, which gives us 5.71 newtons to 3SF. And we can do exactly the same to find TB, because TB over, well, TB is this side here. So it is opposite the 60, so TB over sine 60 equals 7 over sine 70. Therefore, TB equals 7 times sine 60 over sine 70, which is 6.45 newtons to 3SF. And this clever method is called using the triangle of vectors.